A common application of exponential functions or an exponential function is compound interest. And I like compound interest problems. And it comes with a little bit of a formula. Well, not just a little bit. Where we got A, let's say, and A is the account value after a period of time, is equal to the principal times 1 plus R over N raised to the power of R, excuse me, not Rn, T. Okay, now what does all that mean? All right, so A is the account value. This is what we hope to achieve after the interest is compounded for a while. P is the principal, the amount of money we start with. 1 plus R, the R is the rate of return expressed as a decimal. N is the number of compounding periods. And then that's all raised to the power of N times T. N again is the number of compounding periods, and T is the amount of time for which the money accrues compound interest. So here we got a problem. It says if $1,000, that's the principal. This is the P, is invested in an online savings account earning at 8%, and we're going to express that as a decimal, 0.08 per year. That's the 0.08 is our rate of return. How much will be in the account at the end of 10 years? Well, 10 years is our T. This is T. This is R. If there are no other deposits or withdrawals and the interest is compounded. And then we got 3 compounding periods, semi-annually. So how many times would it compound if it's a semi-annual compounding? Well, that'd be 2 times per year, every 6 months. Quarterly, that's every 3 months. That's 4 times a year. And daily, well, daily would be 365. So, in this formula, A, that's what we're trying to determine, how much money is going to be there in 10 years. Principal is 1,000 times 1 plus the rate of return, 0.08, over N, that's what is going to change. 2 times if it's semi-annually, 4 times if it's quarterly, 365 times if it's daily, times N, in this case 10, because they're asking us after 10 years. Well, why don't we go to the calculator and let's calculate this. All right, we're going to complete these compound interest problems. And so remember, A is what we're trying to find. This is the value of the money after a period of time and compounding periods and rate of return. So I got P, 1,000, times 1 plus, I need to hit a parentheses in here, 0.08 divided by 2, semi-annual was our first option, double close of the parentheses, hit the caret button, raised to the power of 2, and we're doing semi-annual compounding, times 10, remember it's over 10 years. Let's hit enter and let's see how much money, how much our $1,000 has grown. And it grew to $2,191.12. Well, how about if we compound it quarterly? Well, again, I got 1,000 times 1 plus, in parentheses, so my calculator reads this correctly, 0.08 divided by 4, double close of the parentheses, raised to the power of 4 times 10, or 40. I could just put 40 in there and not have to enter it that way if I wanted to. And let's see how much more we may have if it was compounded quarterly. $2,208.04. So what we picked up about $17, not quite $17. just for, of course, that's over 10 years, so it's not much, $1.70 on average per year, but hey, every dollar counts. And what if it was compounded daily? So again, I got $1,000 times 1 plus, in parentheses, 0.08, that's our 8%, divided by the daily compounding, 365 days, double close that parentheses, raised to the power of 365 times, that's our 365 is our daily compounding, 10 is our number of years, 10 years, let's hit enter, $2,225.36. Well, okay, not bad. Another 17 bucks if it's compounded daily. So, the more you compound, the more often you see the compounding, the larger amount your account balance is going to grow. I really love compound interest problems, probably because it appeals to my nature as a former banker.